Hello everybody, this is Dave Schopius. I've gotten a couple of requests to do a video of my arm with the skin off. There's the skin over there. The last video I did had the skin on, and the skin actually goes from this point all the way back to the torso of my robot, my B9 robot. This is the arm for my B9 robot that I'm building. It's fully articulated with 4 joints. I'm going to try to run through this whole thing. I'm going to take my time. It's probably going to be a long video, so bear with me. And I'm going to try to do it in one take. So if I make any flubs or say any bad words, well, we're just going to have to deal with that later. So anyway, whoops, like that. Without any further ado, here's some close-up shots. I'm going to try to go through this thing from front to beginning. Front to end, and then afterwards I'm going to show you a couple of my prototypes if you want to hang around, and all that jazz. And I'll show you the robot too, and where it's going to fit into him. Again, any apologies right now for any kind of problems I have with this video, but well, deal with it. Anyway, it starts out with the motor. That is AME motor that I got at Servo City. I'm sorry, not Servo City, but the robot marketplace. A lot of this stuff I did get at Servo City. This motor itself is the strongest motor, windshield wiper type motor I could find. I'm not going to give you the specs right now, so look them up. It's a 226 long nose. It's the strongest one they have. So this this motor, the motor is mounted on a design that I built for this motor mount, for this motor. It's machined and milled, so it was quite pricey to do. We won't get into all that, but it's all machined properly and nicely. Nice smooth edges. It was made out of a piece of angle iron, 4x3 angle iron. As simple as that. It's a little heavy, but I needed the rigidity for the torque that this motor puts in. From stem to stern, from here to here, is like 22 inches. 22 inches. And I had to whittle everything down the best I could so it'll fit inside the torso fully retracted of my B9 robot. And I think once it's fully retracted, I'm still going to have to maybe cut off the edge of here, this corner here, just to get this buttoned up against the back wall of the torso. And then she'll be fully retracted, and when she goes out, it'll be fully extended, hopefully. I haven't tried it yet, because right now I've got it bolted right down to the workbench, because this thing puts out a lot of torque when it's flying up and down. And it holds up. It really does. So anyway, getting on with the tour. The motor mount itself, now this was a kind of a cool thing that I had no idea what I was going to do, because the original bearing I had in there just was not going to hold up. You can see how tight that clearance is. This motor mount is put together with a this is more aluminum plate. I'm not going to give you the dimensions or anything. I just don't have them in front of me. Not that I don't want to. And it's just a regular shoulder bolt in there. And the whole secret to this thing is this little bearing right here. And my machinist turned me on to this. And he says, Dave, he says this salesman was in here showing off his bearings and his line, and he's got this little plastic bearing that's an industrial grade that's supposed to stand up. The company is Ingus, I think it's IGUS. I don't know how to say it, but in IGUS.com they make industrial plastics. I says, man, I don't want plastic in here. That's not going to handle it. But the deal is, it's a polymer, and this, with the load I'm putting on this thing, they figured out that this thing can run continuously for almost 3/4 of the year or more, 3/4 of a year or more, and not get to the point where it starts to wear out. And if it ever does wear out, it's just a matter of loosening up this shoulder bolt here, taking this off, and popping a new bearing in there. It's just as simple as that. And it glides like glass. It really does. Now again, you'll think, first thing I thought was I gotta beef this thing up somehow, because it's just attached right there. There's no linear side mounts or bushings or anything. But what I did is I came up with a, I guess I'm going to toot my horn a little bit throughout this thing, but it took me a while. I had this is like the fourth version of this I built. I'll show you the prototypes later, but it's all locked together with like pillow blocks and number 6 screws, machine bolts. I got 8 of them running through here, around here, going up into the arm. And I guess the weakest point is going to be the heads of these bolts, but I figure you add all that stuff up and you got like almost a ½ inch of steel running through there in different ways, and it's all interlocked in there with pillow blocks. I've got 3 pillow blocks, one butted right up against here, one a little bit up with a steel spacer in between. This is all aircraft aluminum. Another pillow block right in here. Pardon my bad skills here, but you can see I've got like 4 of those number 6 bolts running out from inside to the last pillow block, and they're interlaced back and forth. So you have a couple of like 2 holding it one way and 2 holding the other, so they're just squished in there, and then 4 more running out to the outside here, and I have nuts in the back of there. Don't know if you can see them, but the other part is these pillow blocks are all attached up and down on both sides to the arm itself, the channel, with steel spacers interlocking them back. So you got every direction being held with the load spread out around the whole thing. So it snugs it. Everything's bolted right to the steel, or to the aluminum plate here, with interlock back and forth. Everything's butted up against it. The load is distributed here, in through the center, out over the back, and back to the front. So the actual stress point is way out here. And this is all like I said, just you got to have at least 3/4 of an inch of aluminum in there on those pillow blocks, and then a ½ inch of steel running back and forth, plus these steel reinforcements on the outside and the bottom. All these parts were gotten from Servo City. It's their robot building line. This is the channel I'm using. Like I said, it's aircraft aluminum. I don't know what the numbers are, but it's strong. It's just freaking strong. I mean, you can bend it a little bit, but once you get it reinforced with stuff, this stuff will not bend. It's just strong as heck. You can see how I've cut it, shaped it. That was a 12-inch piece I put along here for the main arm. The main forearm rather, coming out to the wrist joint. And like I said, I got this on Servo City. I'm going to swing around here and show you. So I just got a boatload of parts from them. They've got everything from locking hubs to servo hubs. These are some of these spacers. They got all sorts of spacers and nuts. Different gear sets for different motors, hubs, aluminum spacers. Like I said, I just got a boatload of this stuff, servo stuff. I didn't know what I was going to be building and how to do this, so I just got, and this stuff's dirt cheap. It's dirt cheap. I don't know, I didn't know how I was going to be building this, what I needed, so I just kind of made a guess and got a few of these and a few of those, and this is what I came up with. Anyway, moving along, the again, from this point out is mostly the line from Servo City Bear with me and I'll tell you what the line is. Pardon my shakiness. It's their Actobots line. Just amazing stuff. I had to do a little bit of drilling, a little cobbling here and there to get everything to line up sometimes. I drilled out some pre-threaded holes. They've got stuff that's already pre-threaded, but I got everything threaded and drilled out my own holes because I didn't know what I needed. Some were interlocked. I used regular screws to screw into pre-existing threads. Some like these, I drilled out the pre-existing threads, ran through to the pillow blocks because that already had threads in it. This is all number 6 32 screws. It's very simple. Getting to the rest of it, this is a Servo City Actobots gearbox that I got. It sits inside the channel. They've got them that will actually adapt to the end of the channel, and they get different styles. I thought this was the best to go because I needed everything to fit inside of that little hole there. So that's like 5.5 inches across, 5.5 inches. So I had to have everything to fit inside of there, and to get as far as measurements from here to here, I've got like maybe 4 inches from the outside to outside, 4.25 inches. So it works good. This slims down through here. I've got everything mounted in here. This again is sorry about that, I'm getting excited. This is a Servo City gearbox. I've got this geared 7-to-1 ratio. I can probably gear it down to maybe 5-to-1, but this thing moves pretty fast, and the bigger the ratio, the more load you're going to take off that servo in there. As far as the servos, I got the largest, most torquiest servos in their class. These are just I'm not going to give you the numbers because again I don't have them. This is just a standard size servo that fits inside of a servo gearbox, and it's pardon my skills again. It just gears from very small little bitty motor all the way up to this big thing, and this thing will there's no way to stop this hardly. The only thing is you got to make sure you don't get your finger caught in there because it'll rip it off. You'll take off some skin. I got to build a bonnet or something like this. The arm rubber does not really get caught in there, but I don't want it wearing over time because that's rough. I actually had to duplicate one of the angles that Servo City has. This here is one of their stock angles. This one here is another stock. Is a copy of a stock angle because once I put it together, it was sticking way out here, and I saw some added space I could take up. Again, remember I had to shorten this up the best I could, so I brought that in a little bit, redid this, and the deal is we got a big weight. This thing weighs about 3 pounds hanging out here with everything installed and laying on there. The brackets that I built to make it all come together. For you club guys, this wrist I bought from Craig R. He's on the vendor pages. It's his lightweight fiberglass wrist. There's no way I could build a bracket to go onto the here because this is so thin and lightweight. It started cracking. You can see I tried at one point and started cracking. About crapped myself because these aren't cheap. Bill K puts out a resin wrist and set of claws. I took the wrist off of his and I used the claws with his mechanism here, and I actually retrofitted it into here. I put my brackets so they could, and I had to do a bunch of cobbling. I'm not going to go into how I did that, but I had to cut the wrist centers out a little bit. So this would slip in through the front, and I attached everything with panhead screws so it would be flat, coming through the back, so we have nice good sturdy attachment and support, and it's not supported to the wrist at all. It's supported right to the wrist centers. Now you'll probably think, holy crap, he's got those ugly looking holes, those ugly looking screws right there. I'm going to take and put a piece of styrene in there. I think that's how you say it. It's paper thin. I'll cut it, lay it in there. You'll never see this. It'll look good. Run a little caulk around the outside out there, a little bead of caulk, and paint it, and it'll look like new. The other thing that I'm kind of proud of is the wrist back and forth mechanism. This thing, it goes up and down. It also goes back and forth. That, like I was getting, there's a lot of weight hanging out there, and it's asymmetrical. And how do you support all that? Basically, I've got a couple little systems in place here. First of all, I built this little housing here out of some of that channel. This stuff here, I cut it down, and attached some more of that Actobots parts, kind of customized some of them, and again, we've got all those little bolts back there running through and attaching right to here, back and through here. I've got a spacer that a steel spacer screws in, and it distributes the weight through about a half inch of bearings that spread the load out across the top of this channel, right through the base here around the top and back into this plate right here and back to the center. So I guess the weak part of this whole thing would be probably, heck, I don't know, right here. There's actually no load at all on this servo right now, at all. So it's all it's going through here. You can see how sturdy that is. Back to here. I guess the weak point will be right here, in this little pin here. But there's like a half-inch piece of steel, I think that's half-inch, going through here to a potentiometer back inside there. You can see how that's all mounted in there. This little guy gets a little hot. There's a heat sink on it, you can see it, and it's not too bad. It doesn't overheat, but it gets warm. That's what the heat sink's for. But I'm not going to be running this thing 24/7 either. So I guess what we got here is the next thing I had to figure out was this weight is supported out here by itself. I had a problem with everything when everything was not powered, this wrist sagging down. And how do we support that? So I came up with a pretty good idea, I think, of using just a little door latch that runs in and out. You can see it here, in and out. It's just a brass latch. It's lightweight, it's strong as hell, and it runs in and out through another servo here that actually pulls out of the way when I want to operate this thing down, and lets it down, and when it comes back up, when the time's right, it'll turn it back the other way. Stick it back out for support. Let me take this up and I'll get you a better shot. Okay, now we'll get into the operation later. You can see again what I got here. Underneath, get some of these out of the way. There's an underneath shot of the main wrist servo. There's that little mechanism I talked about, the slide, the support slide, and it works pretty freaking cool, really. And there's the servo that opens and closes it, and that's all attached through a little custom bracket I made that attaches to the bottom. I hope I'm not making you guys seasick with my with my shooting. I am not a professional. So that brings us to the claw. Oh, one more thing. You can see how this thing is just holding this up. That windshield wiper is a gear motor, and I've in my software I've got it programmed to turn the power off to it when it gets to position. So it's pulling no load at all right now. No load at all. It's being held in place. You can't push it. It's locked in place until I decide to move it again. The claw motor, I'll get back to this in a minute. The claw motor itself is just a simple servo mechanism. It's just a mini servo that I've got mounted in there. I don't know if you can see that very well. And it's mounted to the side of my bracket. And I've got some more of those Octobot spacers built up with a little plastic acrylic polycarbonate piece of plastic that I cut